name is Michelle, and I'm part of Team Legend as the outreach lead.
I'm Julia, the hardware lead of Team Legend.
I'm Brandon, the software lead.
I'm Grace, and I'm on the software team.
Yeah, she's not on here because we didn't know she was present, but yeah.
So we'll start by talking about the first tech challenge competition. So the first tech challenge competition is part of FIRST, which is a global nonprofit that has a variety of different robotics programs for students of all ages. So over there's an FLL team, which is basically the first program that is for elementary schoolers and middle schoolers, and we used to participate in that. Now we currently participate in FTC, which is another competition hosted by FIRST for high school students. In FTC, students in grades 7 to 12 can have up to 15 members per team, and every year there's a different theme for the competition. So there's 3 main divisions in an FTC team. So there's a hardware team, a software team, and an outreach team. So FIRST likes to prioritize not only a robot, a good working robot, but also outreach, for example, promoting the competition, promoting robotics in your community, things like that. So I'll introduce our competition from this year. So each year there's a different themed competition, and this year the theme was Into the Deep.
Team.
So this is the competition field for this year, and essentially what we have to do is, so there's 2 ways to score points in this competition. The first way is to take samples from inside the submersible and score them into the high basket, and the second way is to take samples from the submersible, put a clip, use a human player to put a clip on the sample and hang it onto the high bar. So usually in an FTC competition, there's 2 different sections in the robot game. There's 30 seconds that are pre-written code, which is autonomous, and then there's 2 minutes of driver control period, which is when we have a driver controlling the robot to score points. And it's also in a 2v2 format, which means that your robot must be able to work well with other teams, as well as anticipate how your opponents may affect your performance.
Team consists of
Sorry. Again, we started in FLL where we competed for 3 seasons before entering FTC as a rookie. That season we placed 7th at regionals and started our nonprofit organization Suits for STEM, which is a key part of our outreach. More on that later. In the 2023 to 2024 Center Stage season, we won the Connect and Innovate Awards at qualifiers and further expanded our community outreach. And this season, we actually had the highest OPR in our division at regionals and extended our outreach to the international. And some of our future plans, well, we're currently ranked number 30 in our OPR worldwide, and we plan on hosting more annual events and mentoring other LLCs.
So now I'll be talking about the hardware of our robot. So if you guys saw the FLL booth over there, you can see that basically what they have is they have a robot that tries to accomplish a variety of different missions in a pre-written run. But the big difference between FLL and FTC is that in FTC, you're not trying to accomplish a variety of different missions, but you're trying to be the best at repeating one specific way of scoring. So basically, you're basically competing for how fast you can get a cycle, which is how fast you can, like, in this year's game, take a sample from inside a submersible and score it. So here's a video of a robot. So I'll show the part where we're basically cycling samples. So you can see that we just basically kind of repeat the same action over and over again, taking a sample from the wall and hanging it onto the second level. So this is one of the 2 ways to score points in this year's game. And your goal in hardware and software is basically just to be able to cycle this as fast as possible to get as many points as possible in a game. So here's an example from a previous year's game. So in this year's game, you can see that the main objective was to place cones on a junction, and this robot is able to basically cycle that in 3 seconds and do it over and over again. Yeah, and another example is from our second year So in this year's game, the goal was to place pixels on the backboard. So you can see that this robot can really quickly intake the pixels and then outtake them onto the board. So that's kind of how the game works. And then now I'll talk about the specific hardware of our robot. So we use something called a mechanism drivetrain. You can see that our wheels are kind of special because they have these 45-degree angle rollers. And this allows our robot to move in unique ways that a regular, for example, a car or other vehicle would not be able to. You can see that it moves side to side and diagonally without having to turn. Yeah, so this is really easy for our driver to control, and the way that it works is that you can see that these angled rollers allow for, by controlling all four wheels independently, you're able to accomplish all these different types of motion with just without turning the robot. So,
Mechanic?
so I'm just going to play a little bit of this video to show.
Mechanic wheel-fitted robots or industrial machines can make a 180-degree turn without taking much space, whereas a normal forklift takes a lot of space and time to achieve the same task. Consider this perfect sideward movement of mechanic-wheeled machines.
Yeah, so that's kind of the drivetrain that we use. And then moving on to some mechanisms. So a really important part of the robot for every year's game is the intake. So because our game revolves around game elements, we want something that can really easily grab onto game elements. So each year we have a different type of intake. So we use, so far in all these seasons we've used grabbers, but another type of really common intake used in FTC is called the active intake. And basically, you can see that it uses like rollers. This is an example from this year's game. They have a color sensor on the roller intake, so that as soon as it detects the correct colored sample, it's able to intake it. So for the red one, it does not take them in, but for the blue one, it can immediately intake it. So I'll show this later if we have more time, and I'll just move on to software. Oh, and wait, one more thing about our hardware process. So one thing we do before we actually build the robot is we model it on CAD software, which is computer aided design. We currently use Onshape before we start to actually build a robot, and then finally we have to document it in a 15-page engineering portfolio.
Okay, moving on to software. First, I'll talk about how most teams program robots in general. So, there's three main programming tools that teams can use: Blocks, Onbot Java, and Android Studio. Blocks is the most basic version of FTC programming, and it's a visual drag and drop interface. So any rookie team, any novice programmer can use it. And then the next step is Onbot Java, which is text-based Java programming, and this requires some Java experience, but not too much. And it's a good transition to Android Studio, which we just switched to this year, where we have access to advanced libraries and tools. It's a professional app development IDE, and it's recommended for advanced programmers, but it's very worth it if you manage to get it working.
Next, I'm going to talk about how our robot moves. So we have 30 seconds of pre-written code and then 2 minutes of driver control movement. And because the game field has a lot of obstacles and we also have limited time, we have to optimize our movements, making them move quickly and also accurately. So this year we can use Roadrunner because we switched to Android Studio. So Roadrunner is a software that uses PID to help us control the position and velocity of the robot. This helps us create complex movements such as splines, as you can see over here. And PID is it's a loop of calculating the error between the robot's target position and actual position and tries to fix that. autonomous period, which is 30 seconds, and this is all pre-written code. As you can see, it's like really complex. The movement's like curved, and that helps us save time. Okay, so for our arm, we also use PID to control the arm because we have to accurately reach the preset positions. As you can see, we have to retrieve the sample from the ground and also put it in the basket and hang it on the bar. So it needs to move to the correct position or else it won't work. And for our 3 servos, we also control it using a state machine, which times our servo's movement to the arm's movement. That way it's easier for our driver.
Okay, for outreach. So this season we have 3 major projects, the first of which is our organization Students for STEM. Our members and volunteers gained over 1,500 hours of volunteer service through working at camps, showcases, and fundraisers that we've held through our community. Another project we had was working with number 5773 Ink and Metal, which we worked with to set up a new region in FTC Ghana through contacting hundreds of teams for donations and eventually securing 25 successful donors of parts. And finally, our Global Idea Exchange program, where we met with 15 separate teams from 30 different countries across the world to exchange views and goals about FTC. And we've also managed to help and mentor team number 1140 Legacy from Mexico. So I'm not sure we have the time to go over every single event, but on the left side, you can kind of see our community impact, which is through mentoring local teams, such as Delta Box back there, as well as Team IDK. And then on our right, we have all the community events that we mentioned before through Students for STEM. And on the bottom, we have our sponsors and grants that we applied to for funding. Any questions?
I have a question. How much does it cost for the whole team to run in a year?
Yeah, FTC is quite an expensive competition, and that's why we have fundraising goals every year. So for this year, in particular, we raised $6,000 by applying for sponsorships and doing fundraising events as well as member donations. So I think this year cost us like around the same amount of money. Like $6,000 per season is a pretty solid amount because the parts are expensive, the events are expensive to run, and then there's also competition registration fees. But there are a lot of grants that like FIRST offers as well as sponsors of FIRST, and there's a lot of like companies that are willing to sponsor FTC teams.
And also, how much time do each of you devote? I mean, give us a range, maximum and minimum.
Well, minimum would be 2 to 3 hours. We meet for 2 to 3 hours weekly on Sunday as a sort of general meeting. But most of our members work asynchronously or come into the garage at different points of time or different days of the week. So for me personally, I dedicate at least an hour per week, an extra hour for outreach. So
yeah, and then that varies. Like leading up to the competition, a lot of us spend like over 15 hours a week, like working on the robot in preparation. So it just depends at what point you are in the season, as well as like what your team is.
If you guys have any more questions or are interested, we're on the right.
How long have you been
Give her the mic. Give her the mic.
Okay, we can't hear the question.
No, break.
Yeah, what's the question? Go ahead.
How long have you guys been doing robotics, like constantly?
We've been an FTC team for 3 years. Our first season was in 2022. Before that, we were an FLL team.
Besides for us, the Delta Boss, have you ever coached other FLL teams?
We mentored a team called Team IDK for their innovation project.
any other questions?
How do people get in contact with you? If they want to sponsor you or donate to you, how do they reach out?
So our email, which I can leave like after the presentation, is teamlegendftc@gmail.com, and we do have a website that I'll also give the link if anyone's interested. They can come over to our booth. And usually, if you're asking about like how we acquire sponsors, we usually send out a lot of cold emails. Like it's usually us reaching out to them rather than them reaching out to us.
Yeah, no one ever wants to give away money. Yes, in the back. I'll bring a mic to you.
I wanted to ask if someone was interested in joining an existing team or starting out with this, how do they go about that?
Well, currently our season has ended since we did not qualify for the World Championships in Houston. So it's most teams off season right now. If you'd like to join, I'd recommend sending an email or trying to get in contact with local members. They might be recruiting soon.
Also, usually like if you're in a middle school or high school, usually there's like school teams that like every season, because seniors graduate, they usually have open spots. So if you really wanted to join the FTC, like there's a variety of skills that would be helpful to an FTC team. Like even if you don't have like hardware experience, for example, if you know programming or if you're good at outreach, like for example hosting events, team management, project management, or even if you have like any programming experience, like that can all be applicable to a robotics team.
Any other questions?